So I have a pretty sort of self-contained story to share here about our deployment of multi-party computation. I'm not going to define multi-party computation other than what is necessary for this deployment at the point in the story where it's appropriate, so I'm not going to define it up front. There's a lot of people involved in this, despite the simplicity of the mathematics that you'll see, which is going to be interesting. But basically, I just want to, again, give some caveats here. So this is an experience talk, and we're basically going to sort of give a history of what happened and then what our insights and lessons were from that and how we sort of approached the problem and sort of where we're moving forward based on our experience doing this. There isn't going to be a lot of discussion of cryptography or even though those things are involved. Although there's going to be discussion potentially of slightly more rigorous things in terms of human factors and things like that that we're starting to introduce into our work. And again, this is only one application and one deployment, so there may be other lessons and things to learn from other deployments, so this was only one. So the story is that in the city of Boston, the Office of the Mayor and the Boston Women's Workforce Council decided to start this. It's a consortium, and it's kind of a set of best practices for improving pay equity in the large employer organizations in the city. And this does include things like workshops and sort of best practices for companies to follow and so on. But one of the things that came out of this was one of the goals that they had as part of this effort is to actually sort of assess the situation right now in terms of what is the level of inequality in compensation across demographics, across genders, and across different levels of seniority within companies. And in order to do that, you would need to actually go ahead and measure what is it right now, and maybe after you've had these companies participate, follow best practices, go to workshops and so on. Workshops are also for employees as well. Are things improving? Can you track things over time? So as part of this sort of idea, the participating organizations, of which there were quite many, signed on and agreed that there would be some kind of evaluation process that involved, as you see the text there, data being compiled by a third party to do this sort of ongoing assessment. So what happened was basically the original third party that was going to do it, their lawyers said, no, we're not going to do that. We're not going to collect all this information from all these companies at the same time and expose ourselves to that liability. So this was a situation where actually you can talk about whether the companies wanted this sort of information to be private or not, and obviously in some cases they did, in some cases companies don't really care that much. But one thing that's unique about this situation is actually the companies were revealing this information already to another entity, which is the US government. So the data model that was chosen for collecting this data was actually the EEO1 Equal Employment Opportunity form that employers with greater than 50 employees have to submit to the US government anyway. So that also gave you sort of a standard data model that everyone was using. But basically everyone is already revealing this to the government. Basically no other party other than the government who would be able to do sort of the additional analysis on the data once they collected it were willing to actually hold all the data at the same time. So this sort of got through the grapevine to some people at BU, including Andrei Lapetz. And there were a bunch of initiatives, NSF funded and others, where there was an interest in using data and big data and computer science and computational methods to sort of help the city and other similar organizations. So basically, Andrei Lapetz recognized that this was a possible application for multi-party computation. And again, multi-party computation here is in a sense not being used to protect the data necessarily, as it is to essentially eliminate liability for any individual party. So there would not need to be a single entity anymore that has to hold all the data, collect all the data from all the companies, and do that. So the challenge with that was then going to all of the companies who signed on to this as well as to the Boston Women's Workforce Council and the mayor's office, and explaining that this is actually possible, that you do not need any individual company to actually ever hold all the data from all the contributors in order to do the analysis. Nobody has to ever hold that data, and yet you can compute an aggregate function. So again, here we're not going to go into the details of are they willing to compute the aggregate function or not. We assume that basically for the EEO1 forms that they submit, everyone's willing to contribute to this total, and there's going to be enough employers, at least 40 or 50 of them who are going to be contributing that they don't feel nervous about sort of adding their component to that aggregate. And the analysis here is extremely simple. We just basically want to compute the averages. So it's just basically summation because we know how many participants there are. So there was a lot of time spent basically talking to all of these different organizations and explaining to them what is multi-party computation. So in order to do that, there are many much more sophisticated algorithms and protocols and techniques nowadays for doing multi-party computation, but we needed something that was simple enough that you could go to lawyers and CEOs, you could go to heads of IT at these companies, and you could explain it to them in a phone call. That's all you get. You get one phone call, you get 30 minutes. If they don't understand what MPC is, they're not going to be participating in this endeavor. So that's the challenge that we faced. So we took an algorithm that's quite old. It's probably 30 or 40 years old, I don't know. So here it is. Here's a diagram of it. It's pretty simple. So let's say that two companies basically want to compute the sum of their true data A and B here. And at the end of the result that you want to get is just the summation of those two numbers. So it's a very simple technique. I'm not going to go into all the symbols here right now. Let's just take a look at sort of the rough idea. Basically, each contributor can generate a random mask that they can add to their data. And once they generate that random mask and they add it to their data, this basically will look like a random number from just a distribution of large sort of random numbers from a large range. And this is OK to share publicly and reveal. This you can just encode using RSA encryption or whatever your favorite encryption technique is, and then it's OK to reveal as well. So then basically you can go ahead and add the mask data. If you've got this encrypted and somebody can decrypt it, they can add the random masks. If you have the summation of the masks and you have the sum of the random masks, you can basically subtract the random masks out, and what you're going to get is the summation of the two true values from the original source. So mathematically, this is a very simple, whatever we're using here, the associativity property, basically, of addition. So it's very easy to explain, and you can explain this to someone in about 30 minutes if they're familiar with or remember arithmetic from elementary or middle school. So that was the algorithm that we adopted with a few modifications. So the modifications we had to introduce were the fact that this is where you start getting into the usability issues. The contributors basically they had a variety of different technical limitations. Sort of the lowest common denominator, or sort of the worst case scenarios, are people were running Internet Explorer 7 on Windows XP because their IT department does not allow them to upgrade. You cannot install Chrome or Firefox or anything. You're stuck with what they're using. Basically, the technical level of technical literacy is that these were people potentially who were going to be submitting the data who knew how to use a spreadsheet and how to copy and paste data. So that was the level of tech. Nobody was going to be running servers or installing virtual machines or any of that stuff. Sort of, even though some of them could, I'm sure Raytheon could do that or State Street could do that. Many of them could not. So we had to sort of slightly modify this protocol so that you were able to have essentially a single service provider, which in this case turned out to be Boston University, that would do the computation but basically never have access to the data. And then you would have one analyst, which in this case was the Boston Women's Workforce Council, which would hold the keys essentially. So there would be only one set of keys involved. And here, the sort of the weakness of this protocol is that if these two parties decide to collude with each other, obviously the mask data stored on the service provider's servers and the key for opening up the random masks that the analyst holds, if you put those together, you can of course reveal all the individual entries of the data. However, these two parties have no incentive whatsoever to collude with each other because for a number of reasons. First of all, this would affect their reputation and the opportunity at least for the perspective of BU, for example, of ever deploying something like this again and sort of participating in this kind of situation. Likewise, the Boston Women's Workforce Council would not want to collude because they would not want to essentially endanger their data collection and analysis that they're doing. So in this case, MPC is essentially making it possible for no party to be individually responsible for holding all the data, and none of the parties who could collude have any reason to do so rationally. So this kind of asymmetry is what we were trying to exploit, essentially to reduce the number of parties that have to have technical expertise. We were able to make it so basically BU was the only party that needed to know how to run a server and how to sort of set everything up. The Boston Women's Workforce Council also got an interface that they could run in a browser, except they did have to save a file, which was their private key file, an RSA private key file on their hard drive. So that was a little bit more challenging than what the contributors faced, but that's the way that it was arranged. So basically, this application looked like this at the time, and you can see it at 100talent.org if you want in its original form. It's now just an archive. We're going to use a newer version the next time we do this. So that application was actually deployed twice. The first time it was deployed was in June of 2015. And again, it's just a web page where literally they already had the EEO1 form. They had an Excel spreadsheet that looked exactly like what they would see on the web browser. And they could, we made sure we got a nice JavaScript library for the tables here. It wasn't that nice. It was kind of a pain. But we actually had some undergrads work on that part. But we did manage so that you could, for example, paste the data from your spreadsheet all the way in there. Admittedly, the first year that we did this, so we did this twice in 2015 and 2016. The first year that we did this, we did not do as many sort of automated error checking things inside this in-browser spreadsheet as we really should have. As a result, there were just by nature of the algorithm itself, right? So if you go back and you imagine that each of the cells is essentially one of these, right? At the end, when you get the total for that particular cell from all the contributors, if even one contributor got something wrong, like they put a salary instead of a quantity of people or something like that, then that entire cell is gone for the whole analysis. So we ended up with 7 of those cells in that table in 2015 actually were basically corrupted because they looked like people had mixed up what kind of number should go in there. So there's all kinds of discussions you can have there about within MPC perhaps doing some kind of error bounds detection or some kind of outlier detection, and there's all kinds of interesting things there. But another approach that one can follow, which we're kind of following right now and trying to pursue, is how do you make it so that from the usability perspective, the usability features of the application prevent or at least mitigate the potential for those kinds of things to occur. Obviously, ideally, you would want to do both. So let's see, is there anything else I wanted to? Yeah, so one thing that we kind of, there's a lot of discussion in the cryptography community about whether the web browser is a good platform and whether we should still stick to using C code. I speak for a large fraction of our group when I say that we believe that at this point, the web browser has won the not just corporate, but in general environment compatibility wars. I think the browser is the universal platform, and at this point, most of the objections to using sort of in-browser cryptography some of us feel we could confidently translate to a criticism of using it on mobile devices, for example, as well. So we believe that using the web browser is, the most effective way to at least address a lot of the usability issues that you encounter when you're deploying these kinds of things. Nevertheless, there's lots of fun anecdotes that we had from this experience that, again, told us that usability is a really important, and sort of the human factors issues are really important in these kinds of deployments. So the deployment, I believe, was scheduled for a Monday. So the plan was to do, actually, this was insane. We thought we were going to do an hour and a half. So the original window was going to be in an hour and a half. 50 plus companies were going to go to the website, paste in their data, hit submit, and be done with it. It turned out that we had to keep it open for, I think, a day and a half. And we still only got a fraction of the companies who got their data in there. I think it was 40 that did it the first year. But in any case, before that Monday, on Saturday, I don't remember who it was, but one of the companies came and had their lawyers contact us and said, no, you still have to sign an NDA. So let's be clear here. They're asking the service provider to sign an NDA as if they are going to hold the data, the EEO1 data that the company is providing. But the service provider can never see that information unless, again, they collude with, in this case, the analyst, because the analyst has the private keys that would allow you to open the random masks. So despite the fact that we spent a lot of time explaining that basically everything on this server can be published publicly. You can just publish it in the New York Times, wherever you want. It doesn't matter. It's not going to be enough information to actually get the data. We still had to, on Saturday, get some BU lawyers and sign an NDA. Another company actually had us asked us if they could do penetration testing on the hardware where this will be hosted when it's running. We just used an off-the-shelf Amazon Web Services server for this, so you actually are not allowed to do penetration testing on Amazon Web Services servers. So obviously, because you'd be affecting potentially the experience of other Amazon Web Services customers. So I think they backed off on that one after we explained a couple of more times that that doesn't really do anything. And the biggest thing, and personally, I always go back to this. I'm a formal methods and programming languages person originally, and I kind of got disenchanted with that way of doing things. And kind of switched over to usability of formal methods, even during my PhD thesis work. But during this sort of data collection, you've had situations where basically people said things like that. If this, I can't get this to work. Like Explorer's just not loading the page. I'm just going to go ahead and fax this to you. And don't worry. The person said, don't worry. I'll take the name of the company off the fax when I fax it to you, so it will be okay. So then, of course, please, no, don't do that. But ultimately, this is the kind of bottleneck. Is if your solution is too hard to use, as we saw in earlier talks today, this is just another data point to add to that argument. So anyway, everyone was very happy with the deployment, despite the sort of initial problems with having some of this data be sort of corrupted by incorrect entries. So in 2016, the data did not have any incorrect looking numbers in it. All the orders of magnitude seemed fairly appropriate. And if you look at the aggregation, sort of at the aggregate data, it seems to be a reasonable fraction of the workforce that we know from, for example, if we compare it to census data and so on. There's a lot of sort of good publicity also where people recognize that, oh, look, NSF funding actually is potentially having a social impact. So this is not like Azar likes to have these kinds of slides. Azar's in a lot of these photos because he's a lot more aggressive about getting the good publicity than some of us others. So I wanted to kind of show, based on our experience, sort of what we started thinking about in terms of, starting to model some of this. And actually, after Sean, right? Yeah. After Sean's talk, we certainly sympathize with sort of this idea of let's start actually rigorously testing these graphs here and start to actually fill in the numbers with, for example, Amazon Turk or something like that, or if we can sort of recruit real people, that'd be even better. But if you think about it, if you take an MPC solution, there's a couple of different things that different parties could care about. And if you have a situation where you have people or entities who are willing to contribute data and analysts who want to analyze that data, then there's a couple of different things each party will care about. So the analysts really care about participation because that makes their experiment more valid, because they're going to have more data, and there's no data like more data. And then they would also like to see that the data is correct, that, for example, errors aren't occurring because people are entering incorrect numbers, and things like that. On the other hand, the contributors might care about security. They might not want to reveal their data, but they actually also care a lot about usability, because the fact is, I suspect we don't really have this information, and we hope to collect it in future iterations. But why is it that only 71 out of 150 participated on the second 2016 collection? I'm willing to bet it's mostly this. It's not the security. So we don't have that information yet, but we're now sort of working with human factors people and people who actually know how to rigorously collect that kind of information and analyze it. We're planning on future collections and future future deployments of this to make sure that we also collect some kind of survey-like information from these things so we can get an assessment of that as well. So there's a couple of different ways that you can then look at the relationships between these. And we're, again, looking into mathematically modeling these relationships, too, because it's really, it really gets interesting. So for example, why is it that participation can have a negative effect on correctness? When you have a protocol like this, like the one that we used, the more participants there are, the higher the probability of an error occurring, of a human error occurring, no matter what kind of checking that you're doing. Ultimately, some kind of human is giving you data at some stage so they can introduce some kind of erroneous behavior into your analysis. On the other hand, if you believe that the data is going to be correct and you're going to share this data, so for example, this data obviously is then shared with everyone, but also with the companies that participated, they would like to be able to, for example, measure themselves against the average and things like that, so that's valuable. So they would also like to see that the data is correct, and this can certainly encourage participation. Now, I get excited about fixed points and things like that because I'm a formal methods person, so I want to see some kind of equilibrium analysis here at some point. We're not there yet, but hopefully we'll get to do that. But there's other things. So obviously, usability probably encourages participation. Participation can certainly enhance security in something like MPC or in differential privacy, for example, as we saw. And again, security may encourage participation in some cases. But one thing that we've realized is really security does negatively affect both correctness and usability. So security affects usability because on all sides, the data contributors, of course, have to follow some kind of more complicated protocol. They at least have to manage their policies and access rights and keys, and that makes a whole mess for them to think about. And security can, of course, affect correctness for the reasons that we've already seen. So that's something that we're kind of working on right now. So anyway, the results of the 2016 collection were pretty good. They were published in a report that you can read right now. It's online. It's a pretty big fraction of the workforce. It didn't, in terms of the wage inequalities, it wasn't anything unexpected. One of the things that we really, at least I'm kicking myself about, is that I wish we had instituted more checking within the browser spreadsheet application, because unfortunately we were not able to compare, I think, wage inequality across ethnicities by gender. So for example, we know that Hispanic women have much worse pay inequality than, for example, white women. But we were not able, or at least the Boston Women's Workforce Council was not able to do that because there was a disparity that could have been due to human error between some of the various dimensions that left them not confident enough to actually be able to draw conclusions this year about that. So we already have a better version that we're working on that we're testing and improving that hopefully we'll do more checking at the interface stage to make sure that if people entered something that's wrong, and again, I mean, we're trying, but people still don't understand. If you make something red, for example, if something lights up red, we had a phone line open during the collections, and people call in and say, like, the submit button won't let me submit. And we're like, are there any red cells on the screen? It's like, oh yeah, there's many red cells on the table. So, that's our fault. That's not their fault. That's our fault. So anyway, so then we finally started talking to human factors experts. We have a couple that we're talking to right now from UMass Amherst. We also welcome others if they want to talk to us. But basically, we came up with a couple of different properties of our protocol and application originally ourselves, just computer scientists, stupid as we are. And then when we talked to human factors people, we found out there's like a vocabulary they use that's pretty standard. And so there's a way, fortunately, to map ours, so we weren't completely off. But obviously, it's better to use something that's from a textbook from like 30 years ago than something that we made up in a paper. But there were a couple of properties that were interesting. So obviously, familiar interface compatibility with existing infrastructure and all that is nice. There's a couple of things that were interesting to the protocol. So particularly asynchrony is something that we had to introduce into the protocol. So the original protocol as it was published required that the participants actually go in the same order twice. So you got to go around, everybody submits their random number plus their true data to each other, and then you got to go around again to subtract out the random numbers, and you have to do it in that particular order both times, or you actually end up leaking information or not getting the right result. So the architecture that you saw actually does guarantee asynchrony. So that that means basically anybody can submit anytime they want in any order, and you still get the result at the end. So you can check that if you look at the protocol. It does have that property. The other one that was really important to us was idempotence, because you want to be able to have the contributors submit multiple times if they mess up and still be able to basically overwrite their original data. So those were two properties that it's kind of weird because they obviously map to multiple things here, but sort of low errors and efficiency are kind of where they go. So this stuff is, of course, very high level. So we actually had the human factors experts. So Shannon Roberts is the person from UMass Amherst, and her student Rose Kelly. They actually did like a real I think it was a heuristic evaluation. So this is apparently a standard technique that I was not aware of until we started talking to them for assessing something. What was a little amusing is that the spreadsheet that we came up with actually was based on the EE01 form, which is a government form. They didn't realize it at the time, but some of the things they found that were usability issues were actually usability issues with the EE01 government form and not our application. So in trying to make something familiar, we were actually inhibiting the user's experience. But that's certainly a lesson that we learned as well. So this is kind of a summary. Basically, again, I think one of the important things is that you can use technologies like MPC in situations that aren't necessarily about a malicious person trying to steal the private data. I think in this case, that wasn't what it was really addressing. It was more this idea that no one was willing to be liable for holding all the data. And I think that the other thing that we learned is sort of this notion that you can separate the functionalities, the roles, and the parties involved. So then I came up with this crazy diagram, but basically the idea here is that there's a lot of different parties that could get involved and that can actually provide services for something like MPC that aren't necessarily just, there's the contributor and then there's the person who does the analysis and that's it. Because, for example, there's other questions you can ask. So we delivered the application as a JavaScript application from a web server. Now, why should anybody trust a single web server on the internet to deliver the right JavaScript application to all these participants? Well, what you could do is you could actually federate that. You could, for example, federate delivery of that across 5 or 6 content distribution networks. It's probably unlikely that 5 or 6 major content distribution networks are all going to collude to deliver the wrong JavaScript code for this particular application. So if you start separating out those roles, then you see really a great opportunity here to come up with new formalisms and new ways to sort of compose these and think about these sorts of functionalities. So that's kind of what we're thinking about right now as well, sort of as a big picture, is how can we separate these out. One of the major ones we're interested in, again, I'm a formal methods person, is sort of separating out the policy and the person who's writing the algorithm. Because the person who's writing the analysis algorithm doesn't know what their privacy constraints are of the data that it's going to run on, potentially because it's going to run in the future, potentially because that might change. So there is this thing called policy agnostic programming. The idea is that you write the code, and that's separate from the policy, and you just make sure that when you actually run the analysis algorithm, the code respects that policy. And I think that's all I have. So this is not nearly all the people, but here's a subset of the various people that helps us along the way. And we're currently still working, and we are looking for more opportunities to deploy MPC, particularly in big data scenarios. We're working also on an infrastructure that hopefully will hook into things. And one thing I want to mention that was relevant to something someone said earlier. So the Massachusetts Open Cloud, it's one of the first open clouds in the world. So it's completely open source, runs on OpenStack. They are interested, and we are interested, in potentially using the capacity of the Massachusetts Open Cloud to have subclouds essentially inside it for addressing some of these MPC issues, some of these communication issues. So if multiple parties could store their data on the same cloud, but the cloud guarantees that it's federated and there's not going to be any collusion happening between the two federated or the multiple federated components on that cloud, you could get around a lot of these communication issues and still sort of get the benefits of these kinds of approaches. All right, that's all I got.
So I think this is great work. I love this story. But I wonder, given that there seemed to be some misunderstanding, how much do you think this would have worked if BU had just offered to collect the results and in the clear and do the computation, perhaps over an encrypted?
We know BU legal counsel very well now. I don't think that it would have. I don't think it would have been impossible to social engineer a legal team at some university to accept this. I'm sure it would have been.
And in particular, if BU had been willing, the women's workforce and all those participants, you think would have been?
So that's a good point. So obviously, not all. We didn't have to convince all 71 or 150. Once you've convinced State Street, Fidelity, Raytheon, and a bunch of other companies, the other ones are like, okay, well, I trust you, and that is one of the lessons that we enumerated. So yes, BU actually is not a signatory. So that's another issue. So I think that's another question that would be interesting either way. If BU is a signatory, it's kind of awkward, but then if they're not, it's also kind of awkward. So those are questions. So I don't think, I'll admit, this isn't, revolutionary. People are willing to share data all the time, and probably they would be willing to share it. But it is interesting that I can certainly imagine more high-stakes situations where you don't want to hold data that would expose you to liabilities that you can't buy insurance for example.
So I'm just curious, do you have any hypotheses of what the 71 out of the 150 that actually provide the data have in common? Might it be that some of the companies that did not provide the data didn't because they felt that they would wind up looking very bad?
I can't, as a scientist, I can't responsibly speculate too much. But I imagine that there was probably at least one example of all of the above, someone who was perhaps not confident about the security of what was being proposed. But again, I suspect most of them it was a matter of scheduling, usability, technical confidence in what was being done. But I can't.
You just published the data that 1 year, 2016?
The 2016 report is publicly available. You can look at it as the aggregate results.
So in particular, if the decision was based on not looking bad, it's not clear how that would have, at least rationally, have affected their decision, given that.
So the second time, they knew 40 people had done it the year before.
Right, and the aggregates are going to be published one way or another. So they're going to be able to compare themselves to the public.
So everybody, this is publicly.
This is publicly available for everybody. Yeah.
I was thinking of like the CRA data or the CRA industry data where you only get to see the data if you have put your own data in.
Yeah, no, this was publicly published. It was, for everybody. Yep.
Okay. I have the wrong.
It's an interesting model, though. I mean, we can imagine other scenarios.
Question that, the point you made, I'm sure there are many situations where that also arises, where people.
I mean, that would make this an interesting analysis in that situation where participation actually is a high stakes thing now because you don't get to compare yourself unless you participate.
Right.
But maybe you don't want to know.
Right.
That's true. Well, that exposes you internally to liability as well, because if you know in the company now we have the public data and we have our own data, what responsibility do I have? Yeah, that's true.
Okay. Let's speak again. Resume.
Thanks.